All right, so this is part 4, which is also the last part of the video lecture on the types of chemical reactions, and we're going to talk about exploding reactions. These are also called combustion reactions. And so this is when a substance combines with oxygen, and it's going to release a large amount of light and heat. Remember, light and heat are energy. So the general form is we have something reacting with O2, and that's going to make a compound with it. So this could be... And so that's what we see. The fuel is A. We need oxygen. We're going to see that light and heat, and then a new compound's formed. So an example here, water is formed from hydrogen gas and oxygen, and it releases a lot of energy. If you've ever seen the video of the Hindenburg explosion, that's what happened. It was the Zeppelin was filled with hydrogen gas, and a small spark ignited it, and it got enveloped in flames because we have a bunch of oxygen in our atmosphere. Methane also works this way. We have CH4 reacting with oxygen, and it's forming carbon dioxide and water. So the oxygen here is going to both the carbon and the hydrogen, and it's going to form carbon dioxide and water, and we balance. This happens with a lot of, they're called hydrocarbons. So ethanol reacts with oxygen to make water and carbon dioxide. So how do we predict our products for combustion reactions? So you're going to see oxygen reacting with either a hydrocarbon or something else. A hydrocarbon is something with carbon and hydrogen in it. So hydro referring to the hydrogen, carbon referring to carbon. So if the fuel source is a hydrocarbon, the products are always going to be carbon dioxide and water. If it's something else, it's probably going to be a metal, and then we're going to follow the rules for putting ionic compounds together. So let's do it. And I'm going to do this practice with the something else, that's also just a synthesis. If I can spell synthesis right. So that's just a synthesis reaction. And so you're just going to follow the rules for that. I'm going to talk specifically about these here and balancing those. All right, so let's just practice balancing them here. So again, we have a hydrocarbon. I see carbon with hydrogen, and we're reacting with oxygen gas. We didn't go into the naming of hydrocarbons, so you're often just going to be given the formula for these. But just remember that carbon dioxide and water are our products for it. Okay, so we just go through balancing. So we have our reactants and our products, and I have carbon, hydrogen, and oxygen. How I recommend going through these, so first we have 5 carbons, 1 carbon, 12 hydrogens, 2 hydrogens, 2 and 3. Notice there's oxygen there and oxygen there. You have to add them together. So I got that from doing the 2 from the carbon dioxide and the 1 from the water. That equaled the 3 that I got. All right, so balancing. What I recommend you do with these is balance the carbon, then the hydrogen, and then worry about the water. All right, so let's go through this. So I'm going to put a 5 in front of carbon dioxide, so that way my carbons are balanced. So now I have 10 high oxygens from my carbon dioxide. I'm putting a plus there because I'm going to balance my hydrogens next. All right. So I have 12 hydrogens. Is that going to work? I have 12 hydrogens on my reactant side. And every water has 2 hydrogens. So I'm going to need 6 waters then to have my 12 hydrogens. And that means I have another 6 oxygens. So that's going to give me a total of 16 oxygens on my product side. Okay? So I have 16 oxygens on my product side. In my reactants, I have O2. So in order to have 16 oxygen atoms on my reactant side, I'm going to need 8 O2s. So that's going to give me my 16 there. Okay. Let's do one more together here. So now I have, so my reactants and products are still the same. I have carbon, hydrogen, and oxygen. 10, 22, 2, 1, 2, and 3. Okay. So going through balancing, all right, I'm going to put a 10 in front of carbon dioxide. That gives me 10. Now I have 20 oxygens. I'm going to deal with the ones from water in a moment. 22 divided by 2 is 11. So I'm going to put 11 in front of there. So I have 11 oxygens from my water. So that's a total of 31. Now, in the previous problem, I just did 16 divided by 2. 31 is not divisible by 2. So a way to solve that, so just watch what I'm doing. Way to solve that is to think, okay, 31 divided by 2. I can't have a fraction of a molecule. But if you were to have a math problem with a fraction that you want to get rid of, you would multiply the whole equation by the denominator to get rid of that. And so we're going to do the same thing here. We're going to multiply all the coefficients here by 2. So now I'm going to have 2 C10H22. So now I have 20 carbons and 44 hydrogens. I'm going to have 31 O2s. 31 times 2 is 62. I'm going to have 20 carbon dioxides. So now I have 20 carbons there. And that's going to give me 40 oxygens and 22 waters. And I'm running out of space, sorry. So that is 22 oxygens there for 62, total of 62. So that is how I balance those. So oftentimes if you find out that your hydrogens, you're going to have an odd number of waters, you're going to have to apply this technique. All right, so give these a try here. All right, and those are your answers. So if you didn't get those, come see me. We can talk them out, figure out where you went wrong. Otherwise, that's the end of the videos on reaction.